And get back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of lead code and geeks for geeks within less than 5 minutes. So without wasting time, let's get started. Today's problem is sorted and rotated minimum, which is marked as an easy level problem. Let's find out what we will be given into this problem and what we have to do. So we will be given one array ARR of integer type and its constraints will be key ARR length can be anything from 1 to 10 raised to the power 6 and array elements can be anything from 1 to 10 raised to the power 9. Okay, all right. And what we have to do, so basically this array which we are given is rotated sorted array. Rotated sorted array means, first of all, if you will see this array, it is 5 6 1 2 3 4. But if you will, let's say, rotate this two times to left, rotate this array two times to left, it will become something like 1 will come here, 2 will come here, 3 is coming here, 4. So it will become something like 1 2 3 4 5 6. Okay, something like this if I will rotate it. So initially, let's say it is rotated, it is correct, it's sorted one, but after that it is rotated. So if we will rotate it four times, if we will rotate it four times, let's say in the left side, so fourth 1 2 3 4 will come to the last and 5 6 will come in the starting, so it will become something like 5 6 1 2 3 4. Okay, all right, so it is still sorted but sorted and rotated. Okay, all right, so this type of array we will be given, and what we have to do is we have to find the minimum element and return it. Okay, all right, so I think the sort what is sorted and rotated array will be clear, and we have to return the minimum element from it, and that will also be clear. So now what approach we are going to take, that's very important, what approach we are going to take. So look, first approach is very simple, big O of n time complexity, iterate over this whole array and try to find the minimum element, and at last simply return the minimum element. But look, if we will follow this approach, our time complexity will be big O of n, but we are not utilizing this thing, we are not utilizing this feature which is given, sorted and rotated. Because look, this approach, big O of n time complexity approach, where we will iterate over each element and find the minimum, can be done when we have random elements as well. Random elements like random order. So then we have to use it because that's the only way. But here it is sorted and rotated. So there should be something. There should be something which we have to find out. So now look, if we are given a sorted array and we have to find a specific element, which approach we use? We use binary search. We use binary search. Okay, so can we do something like binary search here? Can we do something like binary search here? Let's find out. So how can we find it out? Let's see. Basically, look, at any point of time, there will be one minima only. Okay, so if you will see any of this array 5 6 1 2 3 4, it will be something like this. If we will find out in mark this in our graph, it will be something like this. So like this much before minimum element, all the elements will be sorted, and after minimum element, all the array will be like with in this much array is also sorted, this much is also sorted, this much is also sorted. Okay, all right, so in this case there can be only one position, where ARR of I is let's say greater than ARR of I plus 1. No, sorry, what I'm saying is, yeah, ARR of I plus 1, there can be only one condition, and at that point our ARRI is the minimum. Oh sorry, at that point our ARRI plus 1 is the minimum. So if we will see it here, 5, so 5 is not greater than 6. Okay, 6 is not greater than 1. Yeah, 6 is greater than 1. So in that case our ARRI plus 1, it is the minimum, because at any other point if we will see, if I is this, let's say 1, if I is 1, so ARRI plus 1 is 2, so 1 is not greater than 2. Okay, so there can be only one opportunity, one variable, one index where ARRI is greater than ARRI plus 1, and we have to return it. Okay, all right, so yeah, that's it. And now let's find out, let's see the whole approach of how we will use binary search here to get our answer. Okay, so what I will do, first of all I will check if my ARR of 0 is greater than, is less than, ARR of 0 is less than ARR of last. ARR of last is what? Last is n minus 1. If this is correct, if this is true, it means our array is sorted and not rotated. It's sorted but is not rotated. So in that case, we will simply return ARR of 0. Okay, all right. So first condition is this: ARR 0 is less than ARR of n minus 1. Okay, because look here, you will see 5 is not less than 4. ARR 0, 5 is not less than 4. Okay, it can only happen when the array is sorted, something like this: 1, 2, 3. Here ARR of 0 is less than ARR of n minus 1, and that way our ARR 0 will be our answer. Okay, all right. So first thing is done. After that, what I will do, I will simply calculate our beginning and end. We will simply find out our beginning and end. So how are we going to do that? Look, let's say my beginning will be 0 and ARR of n minus 1 is ARR of let's make one array. Let's make one array. Okay, so our array is something like, let's say, 6, 7, 1, 2, 3, 4, 5. Okay, this is our array. This is our array, which is rotated 2 times to the right, because if we will rotate it 2 times to the right, our array will be sorted. Okay, so beginning is this, end is this. Okay, all right. After that, what I will do, I will simply find out our mid. I will simply find out our mid, and our mid will be this two. Our mid will be this two. Okay, all right. So now how can we decide whether to go left, whether to go right, or our 2 is the minimum? Our 2 is the minimum. So three things are there. Either my 2, our mid will be the minimum, either I have to go to left, either I have to go to right. Okay, all right. So first way, how can we find out ARR mid is the minimum? Okay, so how can we find out? You should also think once. Okay, so if you remember the first condition which I told, if ARR mid is less than ARR of mid plus 1, mid minus 1, ARR of mid is less than ARR of mid minus 1. If this condition is true, if this condition is true at any point, it means our ARR of mid is our answer. ARR mid is our answer. But here you can see ARR mid is 2 is less than 1. ARR of mid minus 1 is what? 1. It's not. Okay, all right. So in that case, our first condition is false. Okay, now what we have to do, either I have to go to left or I have to go to right. Okay, all right. So how can I find out that? How can I find out that? Look, I have got our mid, and if our ARR of beginning ARR of beginning is less than ARR of mid. Okay, it means in this case ARR of mid, it means this one is sorted, this much array is sorted. It means this much array is sorted, otherwise beginning and mid, this array will be sorted. And after that, ARR of end is greater than, is less than ARR of mid, something like this, something like this. Okay, so if these two conditions are true, if these two conditions are true, ARR mid is greater than ARR of beginning and ARR mid is greater than end as well. In that case, what I have to do, I have to go to right side. I have to go to right side. Why? Let me tell you. Let me tell you. So here you can see 6, 7, 1, 2. Okay, so here 6 is less than or equal to 2. No. Okay, 6 is less than or equal to 2. No. Okay, so what I will do, I will simply move to right. I will simply move to right. But if we will find out one case, let's say, okay, let's take this much array only. Let's take this much array: 6, 7, 1, 2. Okay, this is our array, new array. Let's take it. Our mid will be this 7. Our mid will be this 7. Okay, now what I have told is how to decide whether to move to left or move to right. So if our 7 is the largest element, if our 7 is the largest element, how can I find out 7 is the largest? If it is greater than the beginning as well and it is greater than the end as well. Okay, if our 7 mid is greater than the beginning elements or equal to or greater than the end element as well, both, if it is greater than both, then in that case 7 is our maximum. So if 7 is our maximum, our result will be where? Our result will be in the left side. Our result will be in the right side. Okay, in the right side, because first thing we have already checked if ARR 0 is less than ARR of n minus 1. Okay, so that's why it will be in the right side. And if either 7 is less than the beginning or 7 is less than the end, in that case our answer will be in the left side. So for that you can refer to this as well. Let me delete some part. So 6, 7, 1, 2, 3, 4, 5. Okay. Now our 2. So is 2 greater than the beginning and greater than the end? Both? No, it is not. It is not. In that case, what I will simply move to the left. I will simply move to the left. Okay. So how to move to the left? Simply do end is equal to mid minus 1. Okay. All right. So in that case, our beginning will be B and ending will be this A. Okay. Again, look. Again, I will find out mid. So in this case, our mid will be this 7. Okay. Again, I will check, is 7 greater than the beginning and greater than the end? Yes, it is. It is greater than the beginning as well. It is greater than the end as well. So where I will go? I will simply move to right. Okay. Now both beginning and end are same. Beginning and end both are same. Okay. So again, our mid will be same as well. In that case, our mid will be same. So now I will be 1 again. Okay. So if you remember what I told, how to find out the current mid is minimum if ARR of mid is less than ARR of mid minus 1. Okay, ARR of mid is 1, mid minus 1 is 7. So 1 is less than 7. Correct it is. Correct it is. So what will be our output? Our output will be 1. Okay. All right. So there are three conditions which we have to check, and you can note it down and you can also try to code it by yourself. Okay. All right. So now let's move on to the code section. But before moving to that, if you have loved the explanation, if the approach is clear, please don't forget to subscribe the channel and share your feedbacks. And if you are wondering what is this watch tutorial button, so I have made a very beautiful Chrome extension for you. Let me show you that.
All right, let me give you a quick walkthrough of the extension which I have built. So you will get the link in the comment section, pinned one. So you have to go through that. It will open this UI here. You will be having one add to Chrome button. You just have to add it. You just have to add it. Okay. All right. After that, you will go to any Geeks for Geeks question. You will have to refresh it once so that changes are getting reflected. After that, you will get this watch tutorial button. Okay. This watch tutorial button, it will be here. And on clicking of this, a simple modal will open. And here you can find all the tutorials. Here, first one is mine only, count inversions, which I have just uploaded yesterday, and there are others as well. Strivers is there, and this is tech dose one, Geeks for Geeks as well. Okay, all right. So whatever you want to watch, you can simply click on this, and it will be opened here as well. And if you want to see it on YouTube, just click on watch on YouTube, and you will be moved to this video, and you can watch it here as well. Okay, all right. So yeah, that was it, guys, about the extension, and you can pin it as well. Like you can use this pin, and after that you can use this extension on lead code as well. You can use this extension on lead code as well. Okay, all right. So yeah, that's it, guys. Let's move back to the uh, code part.
All right, I hope you will be liking the Chrome extension and you will surely download it. It's completely safe as well. Okay, all right. So now let's move on to the code section then. So basically, what I will do is, if as you remember, I will simply do what I have told. First of all, let me find out n is equal to arr dot length. Okay, all right. After that, what I will do is, if arr of 0 is less than arr of n minus 1. Okay, in that case what will happen? Our array is fully sorted. Our array is fully sorted and not rotated. So what I will do, I will simply do return arr of 0. Okay, all right. After that, what I will do doing is, I will be taking few variables. Let's first variable is beginning is equal to 0, ending is equal to n minus 1, and yeah, these two variables I think we will be needing, and one more variable I will be needing. No, I will be not needing that. Okay, all right. Now what I will do, while beginning is less than end, I will run this loop, and what I will do first, I will simply calculate our mid. Mid is equal to beginning plus end divided by 2. Okay, all right. After that what I will do, if you remember, first condition is our mid minimum, how can I find out that? If, look, if arr of mid is uh, less than arr of mid minus 1, in that case our mid is minimum, so simply return arr of mid. Okay, all right. But you remember one thing, one edge case you can see here. If mid is 0, our mid minus 1 will be out of bound and our code will break. So to make our code safe, what I will do is, if mid is greater than 0 and end. Okay, so our mid should be greater than 0, because here I'm accessing mid minus 1 as well. Okay, all right. After that what I will do is, I have to check the second condition. What was the second condition? That our mid is greater than beginning as well and greater than end as well. Okay, all right. So how can I do that? ARR of beginning is less than or equal to ARR of end, and then ARR of end is greater than ARR of, no, sorry, not ARR of mid, ARR of mid, what I'm writing, something like this. ARR mid is greater than or equal to ARR of beginning, and ARR of mid is greater than end as well. Okay. In that case, what I told, I will move to right. And how can I move to right? I will simply do beginning is equal to mid plus one. Okay. Otherwise, what I will do? Otherwise, I will simply move to right. And how can I move to right? End is equal to mid minus 1. Okay, and at last here I will simply return ARR of beginning, because that will be at last pointing to our minimum element. Okay, all right. So if I want to show you one more time how these two conditions will work, let's take this array 5 6 1 2. Okay, all right. Our mid for the first time will be 6. I will first of all check if ARR mid is greater than 0. Yes, ARR of mid 6 is less than mid minus 1. 5. 6 is less than 5. No. Okay, so first condition will break. After that, uh, something was like this, and oh sorry, 5 6 1 2, our mid was this. Okay, all right. After that, is mid greater than both beginning and end? Let's see. ARR beginning is 5 less than or equal to mid? Yes. Okay. ARR of mid is greater than ARR of end 2? Yes. So in that case, beginning is equal to mid plus 1. Mid is this, so beginning will become this. Okay, so this will be our beginning, and our end is already at the last. Okay, so in that case, what will be our mid? Our mid will be again 1. Our mid will be again 1. Okay, all right. After that, what I will check? ARR of mid is less than mid minus 1. Yes, 1 is less than 6. In that case, what I will do? I will simply return ARR of mid. Okay, all right. So in this case, you can try as many cases as you want, and you will always get the correct answer. And I hope you have liked this solution very much. So let's try to submit this once to check if it is running correctly or not. Meanwhile, please subscribe the channel, because every time you will get one video when you will wake up in the morning of the POTD. I will be uploading it in the night as well. Okay, night only. So, and please download the Chrome extension as well. Let's see if it is accepting or not. Okay, all right. So it is getting accepted, and yeah, I'm going to see you again tomorrow. Till then, keep on coding and bye.